An introduction to the binomial probability distribution. A biased coin is flipped 10 times. So we have 10 trials. In each trial, we either get heads, which is a success, or tails, which is a failure. 2 outcomes in each trial. The probability of success is 0.6. So we have a fixed probability of success. And remember, success here is defined as getting heads. The outcome of any trial is independent of all other trials. There are 4 key points to note here. A fixed number of trials, only 2 outcomes in each trial, a fixed probability of success, and trials which are independent of each other. To calculate probability, some of the more traditional routes will cause problems because of the large number of trials. So for instance, let's say if we want to work out the probability that we get exactly 7 heads, or at most 3 heads, or the probability of at least 7 heads, we could try a tree diagram approach. So far that's 1 flip of the coin, 2 flips of the coin, 3, and you can see this is an impractical way. We don't want to go to 10 flips of the coin using a method like this. Now fortunately, if these conditions are met, a fixed number of trials, 2 outcomes in each trial, a fixed probability of success in each trial, and trials which are independent, we can use the binomial probability model, which allows us to calculate probability in 3 different ways, either using a formula or using the calculator's inbuilt statistical functions, or using cumulative probability tables. And I will cover each of these methods in separate videos. So here are the 4 conditions that need to be memorized. So trials, well, a fixed number of trials. In each trial you have a success or a failure. In each trial, the probability of success is a constant, and trials are independent of each other. These 4 conditions are usually quoted within a given context. We summarize a binomial probability distribution in this form, where uppercase X is a discrete random variable which represents the number of successes in n trials. So the number of successes can be modeled by, or follows, a binomial probability model where n and p are its parameters. So n is the fixed number of trials, and p is the probability of success in one trial, and p is constant. For practice, try these 2 questions.